Okay, you are going to need your calculator. We are going to be doing that program that I gave you, 2 programs that I gave you last week. Who doesn't? All right, so chapter 6, we're doing the definite integral. Today we're going to do something called RAM. It does not stand for regular advanced math. This RAM stands for rectangular. Write this down, you need to know it. Rectangular approximation method. Okay, these are going to be an approximation right now. You know what they do in this book and a lot of times in calculus? They do it the way the old people did it, and they have you like derive it. It's kind of interesting, but okay. So here's the thing. You can find areas under curves. That's what we're going to do. You can find the area under, say, this line from here to here pretty easily because what does that form? A triangle. So you can use an area formula, okay, for things that you know. Rectangles, triangles, trapezoids, all kinds of things. The problem happens, though, when you want to find the area under something like this. Okay? And so let's say we want to find the area between these 2 points on the x-axis, and it's the area under this curve. Well, how do you do that? It's really hard to do. What we're going to do is we're going to take an approximation. So we're going to take a curve, a very fancy curve, for example. They don't have to all be fancy. Let's say we have some kind of a curve that goes like this. And we want to find the area under the curve from A to B. So we're looking for this area here to here. Well, what we're going to do is we're going to break this up into an interval, maybe like 1, 2, 3, 4, all the same width. And we're going to draw some rectangles under that area. So maybe I draw this rectangle here, and then this one over here, this one. Okay? And what happens is I know the areas of rectangles, and so I get an approximation. But do you see what my approximation, what the problem is? Look see this right here? That's too much, right? All this is too much. It's outside my curve here. And so, but I did take the area of all of this, all these rectangles together, and it approximates what the area under that curve is. We will, at the end of this chapter, actually not the end, but in a couple of days, find out how to do it, okay? It actually involves derivatives, which is really cool. All right, so this is called rectangular approximation method. It's used to approximate the area. Let's write this down. It's used to approximate the area under a curve. And we're going to do this by hand, and then we're also going to do this by the program I gave you, the RAM program, okay? It's hot in here, huh? I know. Now, we're going to have 3 different types of approximation. All right, we're going to have 3 different types. Pause. Oh, no, I'm recording. All right, so we're going to have LRAM, which is going to take everything from the left side and over, okay? So let me go ahead and show you what that would look like. So let's say that we're approximating the area under this curve here. Okay, maybe it's some kind of an exponential curve, or maybe it's half of a parabola, whatever. And let's say that this is A to B, okay? And then they tell us how many intervals to break this up into. We'll break it up into 4 different rectangles. So I need to find the area under here. So what I do is I'm going to start on the left side. LRAM is to start on the left side. So I'm going to start where A is 0, and I'm going to draw my rectangles that way. And then I start on the left side here, and I draw it that way. Left side all the way up to the curve on the left side of the rectangle and over. And do you see what that did? That gave me an underestimate, didn't it? Okay, it gives me an estimate, but it's going to be less than what I know it is. That's called LRAM. Your program will give you LRAM. We're also going to have to find that by hand too. All right, then you're going to have, what do you think? RRAM, that's right. RRAM is going to be done the same kind of way. Let's go ahead and have the same curve. And now let's have from A to B again. And so our RAM is going to be on the right side of our rectangle. So let's go ahead and break this up into the same amount of intervals as our other one, just to show you the difference between them. So our RAM would be to start, I usually like to start over here at B. I mean, you could start at the first tick mark, that would be fine. But you're going to be on the right side of the rectangle is where your curve hits. So it's going to be an overestimate, isn't it? Like that. Yep. Okay, and that one's okay to do. I'm going to show you how to do that by hand with a real problem in just a minute. And then we have one more. We have LRAM and RRAM, and the other one is MRAM. MRAM's a pain in the butt, I'll tell you that much. I mean, your calculator finds it really easily, but for you to have to do this by hand, it's kind of a pain. MRAM stands for midpoint. Okay, so if you have that same curve again, and you still have A to B, you have this broken up into 4 rectangles, then what you're going to do is, you're going to go to the middle between A and this first tick mark. You're going to go to the middle and you're going to go in each direction to find your rectangle. Okay, so you go in the middle of that first tick mark, in the middle right here, and then you build your rectangle out from there. So you go in the middle right here, build your rectangle out, but it's a better approximation, isn't it? That's not splitting it up into more rectangles, it's just going to the middle of it. So you go to the middle, oops, and then the middle, which is here. So what happens is you get some overs and you get some unders, which is nice. And then it ends up being a better estimation. But they're all approximations to what it's going to be. Okay, so I'd like to show you how to do one by hand. We'll do all 3 of the parts. You will have to do one by hand on your next quiz on Friday. You'll have to probably do one on the test too. All right, so here we go. Number 1. We'll just go start off easy. Let's say that f of x equals x squared, okay? And I want to find, bless you, the area under the curve from x equals 0 to x equals 5, okay? Using 5 intervals. That's the other thing. The more rectangles you use, the better your estimate's going to be. I'm not going to make you use 100 rectangles and try and find them on your own. That would be awful. This is going to be by hand. Yeah. So using 5 intervals, each with a width of 1. And that's the other thing I try and make sure. Like if it's from 0 to 4, I would probably do 4 rectangles. If it's, 2 to 12, which is, 6, I'd probably do like 6 rectangles or whatever. Or maybe even, yeah. Okay, so here we go. If you want to, you can draw a picture of this if it helps. I think it does a lot of times, so I'm just going to draw one picture. We have to find, by the way, we have to find LRAM, RRAM, and MRAM. MRAM, that's funny. Yes, we're going to learn that this week, either today or tomorrow. Tomorrow, not today. Okay, so here we go. Here's our picture. This is just your basic y equals x squared. It's a parabola. Looks like this, both sides. We need to find the area from 0 to 5. So I'm going to go 1, 2, 3, 4, 5. We're trying to find the area under that curve. Okay, I'll draw it in red. You're trying to find this area here. Always with the x-axis too, by the way. I didn't mention that. Okay, so let's do LRAM first. LRAM. So we're going to, what we're going to do is we're going to make 5 rectangles, and we have to find the areas of all 5 rectangles and add them up. So our first rectangle is going to start here at 0, and it's going to go a length of 1, okay? So LRAM starts on the left side. So you're basically going to do this. F of 0 times 1. Okay, the F of 0 gives you the left height. 1 is always the width. See how 1's the width of all of these? Okay, plus. Now we're going to do the next rectangle, which is F of 1 times 1. Okay, plus. The next one is F of 2 times 1. We'll figure out all these things are out in a minute. Then we're going to do F of 3 times 1. And then finally, F of 4 times 1. Okay?
Is it always going to start at F of 0?
For L, well, okay, it'll always start at, so this went from 0 to 5, and if I'm doing LRAM, it'll start at 0. Like if I was going from 2 to 8, LRAM would start at F of 2, because it's the left side. And I'll show you how to do the other one in just a minute. Plus. Yes, thank you. Okay, so the first one, well, we know that F of 0 is 0, and 0 times 1 is 0. So my first rectangle is actually it has no area. Do you see that rectangle? It's a flat line. It's this first rectangle right here. All right, so that's 0. My next rectangle is F of 1 times 1, which is 1. F of 2, 2 squared is 4, times 1 is 4. F of 3 is 9, and F of 4 is 16. And so I add all of those up, 30. Perfect. So LRAM would give us 30.
There's no units or anything?
Just 30 square units, yeah. Okay, now let's do RRAM. RRAM is going to be a little bit different. Okay, I'm going to draw it again. And you don't, oh, that's really ugly. You don't have to if you don't want to, but here we go. We'll go 1, 2, 3, 4, 5. Now, with RRAM, it's really on the right side. So you're not going to start at 0. Where are you going to start? Yeah. You could start at the end, or you can start, green. I would probably just start at the first tick mark and go over this way. So that would be F of 1 times 1. The width is 1 on all of these. That's why I hate it when they give you a width of 1/2 or ugh. Plus, my next one would be F of 2 times 1. It's almost like you skip that first number. You go to the first tick mark because you're going to the right. It would go to the left, exactly. Times 1 plus F of 3 times 1 plus F of 4 times 1 plus F of 5 times 1. So this first one, LRAM, included F of 0 times 1, but the last one included F of 5 times 1. So if you notice, it's going to be bigger, right? It's going to be an overestimate. All those rectangles added up.
It's a lot more.
It is a lot more, huh? How much is it? 55. That's too high. Okay, now here comes the pain in the butt one. The midpoint. Okay, so let's talk about the midpoint. I'm going to draw it again. Here we go. We got 1, 2, 3, 4, 5. Goes way up here. All right, so the midpoint would be then to go halfway between 0 and 1, and that's going to be your height. So that would be what? It would be F of 1/2 times 1.
I thought when you said like the midpoint, I thought you like went one way the
Of
other
the
way,
whole
and,
thing?
like, the higher on the other side.
Oh, no, no. So like I go to F of 1/2, and then I draw my rectangle going in each direction
So
and
it's a
down.
little bit under a little bit.
Yeah, so it's going to hit right here, at the midpoint, and it's going to go over and under.
Okay.
Yeah. So here, it's nice that I get to zoom in on this.
So then our second one would be f of 4.5 or 1.5.
Uh-huh. See, that's why it's a pain usually, because they're not going to be nice numbers like you had. So then plus, the next midpoint would then be between 1 and 2, 1.5. So f of 1.5 times 1 plus f of 2.5 times 1. And it's a lot of calculating, you know? And f of 3.5 times 1. And I know I keep writing times 1, and you're like, okay, we know it's times 1, but sometimes it's not. Sometimes your intervals are times 2. So I want to make sure that this is an area. It's length times, or height times width. And then I ended up working all this out. Ends up being 41.25. And you would expect that that's going to be in the middle between 30 and 55. Unfortunately, you can't just take the average, you know. Did anyone think of that? Why don't we just take 30 and 55 out of, you can't. I know.
Your n ram always has to, the number always has to be
close.
Between.
Yeah, wait, why can't
Oh, yeah. Yeah.
42.5 is the average.
I know, close, right? It's a close approximation, but it's not quite it. Yeah. Okay, so now I'm going to show you that your calculator can do this also. And I gave you a program, and you're going to use a program RAM. There's also a program called TRAP. Guess what they do with their approximations? They make them into trapezoids. Right? I would never make you do that by hand. So trapezoid would be, now it's cold in here, huh?
Yeah.
Trapezoid would be like, you know, if you had a rectangle, instead of drawing a rectangle, what they do is they draw like a trapezoid underneath of it. Crazy. Not like that, though. No, it'd be more like, yeah, like that. Like a trapezoid. So that, you get a better. And then they even went so far back, like way before they had calculators or anything, they did something called Simpson's form. Simpson's form, what it would do is it would give you a rectangle, but it made a parabola at the top of it, and they could find the area of those.
How do you find the area of that, but you can't find the area of...
The whole thing, right? You actually can. We will. We will. Okay, so let's go to program RAM. I gave you RAM, trapezoid. I think I might have even given some of you Simpsons. We really are just going to focus on RAM. RAM and trap, yeah. I can show you how to do both of those. All right, here we go. Number 2. So let's go ahead and let's find the area. Same function. So let's see how much better of an approximation is of f of x equals x squared from 0 to 5. This time using 10 intervals. Okay, but I'm not going to make you do that by hand. And let's find out what LRAM is, what MRAM, that should be in the middle, and RRAM. So here's what you're going to do. We're going to go to our calculator. I'll wait and let you catch up a minute. And you first need to put the function into your graphing part, okay? I forget that all the time. So y equals x squared. The program will use whatever you stored there. It knows to use that. So go to y equals, plug in x squared, and then just quit. You don't need to know what it is. You don't need to know what you don't have to graph it. Okay, so go to program, and we're going to choose RAM. Rectangular approximation method. Trap is trapezoid approximation. So RAM, and it says what A value? Your interval is from A to B. In this program, it's a capital A. That's fine. I can even write it like that if you want to. Capital A to capital B. So what is A? 0. And what is B? 5. A number of intervals? 10. And it will calculate it for you. There it is. I know. So LRAM is 35.6. See what a better approximation that is too? Our MRAM is 41.56. RRAM is 48.125. So we could have done it with the 5 intervals and checked our answer to see if we were right. Okay.
You know when you do the average, it's only off by like point two or point 0.24.
I know, right? Isn't that
Really
crazy? Okay, let's do another one, a harder one. Let's do number 3.
All by calculator.
Yeah. Let's do f of x equals 3 over x minus 1. All right. If you were to graph this, this is just, it's got an asymptote at 1, and it's got an asymptote at 0, and it looks like it's just one of those rational functions, you know? Yeah. And so we're going to find the area on the interval from 2 to 4. So here's 2 and here's 4. So what we're trying to approximate is the area here. Now, in this case, see how LRAM's going to be bigger this time? Because see, all of my rectangles going this way are going to be bigger. Yeah, so don't just think that LRAM's always bigger or smaller, I mean. Okay, no, we're going to do 100.
Wow.
All right, we're going to do 100 rectangles, and we're going to find out what LRAM is. Oh, yeah. Your calculator has to think about, I mean, it'll take a while.
They're all so really close.
They're all really close, huh?
3.315, 3.295, and 3.275. Or round it.
Don't forget to plug in the equation into y equals, I always forget that, 3 divided by parentheses x minus 1. And then quit and go to program and RAM. It was 2 to 4, right? 2 to 4 with 100. And then you sit and you're like, oh no, I broke my calculator. I love that. All right, yeah, so you get 3.3159. I don't know, it doesn't matter. You did. Change your equation.
Did you put parentheses around
Yeah. Yeah.
So what would we put in for the A,
2 and 4.
B then?
And then let's do trapezoid. Did I give you the trapezoid one too?
Yeah.
Excuse me. Let's go to program. Let's do trapezoid. It's set up a little bit differently. It tells you number of subintervals. That's 100. Here, I'll take a look at it in just a minute. 2 to 4. Wow, it does it really quickly. So trap would give us even a better approximation, 3.30. We're actually going to find out how to do this and get an actual exact answer.
Number of sub?
To 100. Yeah, it prompts you a little bit differently. So it asks you for subintervals, which is those.
Wait, I got a different number. Oh,
You-
wait, you rounded. Wait. I don't know.
Trap? I did trap.
I got 3.29.
Really?
I got 3.296.
Really?
3.295,925.
How funny. Mine rounded differently then, because everything's the same. 3.29, huh? Interesting.
Super close.
Super close, yeah. Okay, and that's pretty much it.
It's Carrie. Thanks for watching my video. My name is Ji-hoon.